Okay, we're good, we're ready to go. Okay, so I'm just gonna record us going through these two ACCs. If you haven't tried them yet, please pause the video right now and try this one. It's at the end of your Chapter 7 ACC book. All right, Liam and Amy are planning an outing for their group of friends at the zoo. Liam buys 5 entrance tickets and 3 train tickets. He pays $65. Amy buys 2 entrance tickets and 1 train ticket. She pays $25. I am going to let X equal the cost of I'll say an entrance ticket. And I'll let Y equal the cost of a train ticket. There you go. Yes, you have to actually do this. If you don't do what I just did, it will cost you half a mark. So that's about the easiest half mark you're ever going to get from me. Now we have to actually create a linear system. Well, 5 entrance tickets means 5 times X for a cost. 3 train tickets means 3 times Y for a cost. So 5 entrance tickets, there's my 5X. 3 train tickets, there's my 3Y, equals $65. And here, I'll use another color. To get my other equation, I'll use green. My other equation, Amy buys 2 entrance tickets and 1 train ticket, so that's 2x plus 1y. No, you don't need to write the 1, but it's not wrong if you do. Pays equals $25. And there's my 2 equations. Now, use the linear system that you determined, that you created to determine the price of an entrance ticket and the price of a train ticket. So now it's kind of your call. Do you want to do this by substitution or elimination? It doesn't matter to me which way you do it. I'll use elimination. I'll times this equation here by 3. So here, I'll write them down again. So I have this equation, and I have this equation. And I'm going to times this equation by 3. Giving me, this one stays the same. I'm not gonna mess with that one. But this equation now is going to be 6x plus 3y equals 75. And then I'm going to minus the first equation and the second equation so that it eliminates my 3y. 5x's minus 6x's is negative 1x's. 65 minus 75 is negative 10. Divide both sides of the equation by negative 1. And there we go. We have 10. This is the easier looking equation, so I'll plug things into that one. If x is 10, that's my equation now. So 20 plus y is equal to 25. Subtract 20 from both sides, and there we go. Now, normally when you're solving in a system of equations, you just give me the points, x comma y in brackets. But this is a word problem, so just like you got a half a mark just for this thing, you also get a half a mark for your conclusion, and your conclusion is, therefore, use your words. What was X again? Oh yeah, entrance tickets. So therefore, entrance tickets are $10, and what was the other thing? Train tickets. And train tickets are $5. And there you go. Just stopping when you get x equals and y equals and not giving me a conclusion costs you half a mark. It's a word problem. It should have a conclusion statement. Any questions on how I did that? All right. Looking good. Let's go to the other ACC now, the one in Chapter X. And all right, determine the distance of the line segment. So you are given this formula. You don't have to memorize it. But it's x2 minus x1 squared plus y2 minus y1 squared. And let's put the numbers in. Okay, I'm going to call this guy x1 and y1. I'm going to call this guy x2 and y2. So it's going to be negative 4 minus 2, all squared. It's going to be 1 minus negative 3, all squared. And then I got to just do some arithmetic. So this is going to be negative 6 squared, which is 36. And 1 plus 3 is 4. 4 squared is 16. So 36 and 16 is 52. Am I right about that? 6 and 6 is 12. 12, 22, 52. Yep. So my distance is the square root of 52. And right now, I think that's a perfectly good answer. Right? Once we're done the next chapter, and again, when we actually do this lesson, you're going to have to act surprised, okay? You would realize that the square root of 52 has a 4 in it. Right? Or does it have a 4 in it? Yes, it does. Because 52 cut in half is 26, which is still even. So if you can divide 2 into a number twice and not hit decimals, it has a 4 in it. But 4 what's? 4 13s? Yeah, that makes sense because there's 13 cards in a suit and 52 cards in a deck. So yeah, 4 suits. 52 is 4 times 13. So I can think of that as the square root of 4 times the square root of 13. And if you're wondering, why are you allowed to do that? Why are you allowed to split the square root like that? Well, you actually learned that back in grade 9. You learned in grade 9 that if you have, actually I think you used x and y and you used a and b as the actual exponent. In your power laws in grade 9, you had one that looked like that. And then you learned that, oh, you can distribute the power into a multiply. That's called power of a product rule. Well, I'm just using that rule backwards, right? This is, well, actually, no, I'm not really using it backwards. This is 4 times 13 to the power of a half, because that's what square roots are. They're half powers. So that's 4 to the 1/2 times 13 to the 1/2. So that's what I have right here. I'm allowed to split that up. And then this simplifies without a decimal because 4 is a perfect square. So that's what they mean by mixed radical. I won't put that instruction on the test we're doing next week because that's something we should know how to do after chapter 4. Okay? All right, now we got a midpoint problem. Midpoint formula is the average of my x coordinates, comma, oops, that's not what I meant to write. There we go. Comma, the average, comma, the average of my y coordinates. Okay, so again, I'll have to label these guys. That's x1, y1. That's x2, y2. So let's average those numbers. So we have 11 minus 9 divided by 2. And we have negative 2 plus 13 divided by 2. Okay, well, one of these is going to actually be not a whole number. 11 minus 9 is 2, so 2 over 2 is 1. But negative 2 plus 13 is 11. So I'm actually kind of happy with this. I like a simplified improper fraction to me is the bestest answer. I don't want a decimal, right? If the question doesn't start with decimals, don't introduce decimals. Don't go bringing decimals in where they don't belong. Okay, I'm perfectly happy with a simplified improper fraction. Okay, all right. Then there was a whole bunch of these in the homework, and there's a few of them on the review that you can practice. Let's do some algebra. If the midpoint is 6, 3, that means that I know 6 is some unknown x coordinate. See, Q has x coordinates x, y. I don't know what x, y is, but I know that x plus 5 divided by 2 has to be 6. And I know that 3 is the average of these two y coordinates. So I just solve these as two separate equations, and that's my coordinates for Q. So I times both sides of this equation by 2. I minus both sides by 5. I times both sides of this equation by 2. I minus 4 from both sides. Therefore, Q is 7, 2. Any questions on how I did that one? Okay, I'm going to stop my video now, because that's the ACCs for today.